hyperconjugation and organic chemistry. In this lecture, I will teach you the super easy trick to learn hyperconjugation. Also, I will teach you exam questions of hyperconjugation. So watch this lecture till the end and you will learn something awesome. Firstly, I will teach you the concept of sigma electrons and pi electrons. Without learning some of these basic concepts, you will not be able to learn hyperconjugation. Now consider this organic compound. We know that in double bond, there is one pi bond and one sigma bond. In the pi bond, there exist pi electrons, while in the sigma bond, there exist sigma electrons. Now this single bond between hydrogen and carbon is also known as sigma bond, which contains sigma electrons. Thus remember that pi bond contains pi electrons and sigma bond contains sigma electrons. The second important concept which you must learn is alpha carbon and alpha hydrogen. We define alpha carbon as the first carbon atom attached to a functional group. For example, consider this organic compound. Here, the functional group is alkene. This is the first carbon attached to the functional group. Hence, it is alpha carbon. These three hydrogens are linked to the alpha carbon. Hence, these are three alpha hydrogens. Secondly, consider this organic compound. We can see that this is a functional group of alkene. At the right hand side, this is the first carbon attached to the functional group. It is alpha carbon and these three hydrogens are alpha hydrogens. While at the left hand side, this is also considered as the first carbon attached to the functional group. It is alpha carbon and these three hydrogens are alpha hydrogen. Thus in this molecule, there are total 6 alpha hydrogens. Thirdly, consider this organic compound. It is a carbocation. This is first carbon attached to it. Hence it is alpha carbon and these are total 3 alpha hydrogens in this molecule. Lastly, consider this organic compound. Pause the video and try to figure out the total number of alpha hydrogens in it. Well, this is CH2 and this is also CH2. These both carbons are alpha carbons at the left hand side and at the right hand side. Hence there are total 4 alpha hydrogens present in this compound. Thus noted down these very important concepts of alpha hydrogen and alpha carbon. Now what is hyperconjugation? Well, for hyperconjugation effect, we need alpha hydrogen plus sigma electrons. Let me repeat it. For hyperconjugation effect, we need alpha hydrogen plus sigma electrons. For example, consider this organic compound. Here, remember this important trick. In case of carbocations, the positive sign shows vacant orbital of carbon. Let me repeat it. In case of carbocations, the positive sign shows vacant orbital of carbon. Hence, this positive sign on this carbon shows that the p orbital of this carbon is empty. I rewrite this carbocations like this. We can see that p orbital of carbon is empty. Now listen carefully. There are sigma electrons in this carbon-hydrogen bond. Secondly, this hydrogen is alpha hydrogen. Hence, both the conditions, sigma electrons and alpha hydrogen are satisfied. So hyperconjugation is possible here. Now there is possibility that these sigma electrons of this hydrogen will shift to this empty orbital. We get a new structure like this. This hydrogen has given its electron to carbon, hence its bond is broken and we write it here. Remember that when sigma electrons shift, bond is broken. While the positive charge on p orbital disappears because it has gained one electron. Secondly, there is also possibility that this sigma electron of this hydrogen will shift to this empty orbital. We get one another possible structure. Thirdly, there is also possibility that this sigma electron of this hydrogen will shift to this empty orbital. We get the third possible structure. Therefore, We define hyperconjugation as the shifting of sigma electrons to adjacent half-filled or empty p orbital to increase stability is called hyperconjugation effect. Let me repeat it. The shifting of sigma electrons to adjacent half-filled or empty p orbital to increase stability is called hyperconjugation. Remember that hyperconjugation is hypothetical. It doesn't occur in real life. Also note it down that these are the three resonance structures of this carbocation. Thus we learn that when sigma electrons shift to empty p orbital, this effect is known as hyperconjugation effect and it increases the stability of a compound. Now I will teach you two important questions of hyperconjugation. The first question is, why hyperconjugation is also known as no bond resonance? Well, it is because there is no bond between the carbon and hydrogen atoms. For example, consider this carbocations where hyperconjugation effect has occurred. We can see that hydrogen has given its sigma electron to the p orbital. There is no bond between hydrogen and carbon. Therefore, we say that hyperconjugation is also known as no bond resonance. Secondly, why hyperconjugation is also known as sigma pi resonance? Well, it is because sigma electrons are shifted to the p orbital or pi orbital. For example, consider this carbocation. We can see that the sigma electron of this hydrogen is shifted to the empty p orbital of carbon. Due to this shifting of sigma electrons, resonance occur. Therefore, we say that hyperconjugation is also known as sigma pi resonance or sigma p resonance. Thus note down all these important questions. Now let me teach you the importance of hyperconjugation. Well, hyperconjugation helps us to determine the stability of a compound. I mean, the more are alpha hydrogens, the more is hyperconjugation and the more is stability. For example, consider these carbocations. Which is more stable? Well, we can see that this is alpha carbon, this is alpha carbon, and this is also alpha carbon. Each alpha carbon has 3 alpha hydrogen. Hence, there are 9 alpha hydrogens. Here, there are 6 alpha hydrogens. There are only 3 alpha hydrogens, while in this carbocation, there is no alpha hydrogen and even hyperconjugation wouldn't happen here. According to this rule, the more alpha hydrogens are, the more is hyperconjugation and the more is stability. This carbocation has more alpha hydrogens. It is the most stable compound. This compound has no alpha hydrogen. It is the least stable compound. Hence, this is the order of stability. Therefore, we need to study hyperconjugation in order to determine the stability of organic compounds. Now let me teach you one very important concept. In which of the following compounds hyperconjugation is possible? Well, consider this curve. I always write curve. Hyperconjugation is only possible in carbocations, alkene, and free radical of hydrocarbons. Now the first organic compound is aldehyde. Hyperconjugation is not possible in it. The second compound is carbocations. Hyperconjugation is possible. The third compound is alcohol. Hyperconjugation is not possible. The fourth compound is alkene. Hyperconjugation is possible. The fifth compound is free radical. Hyperconjugation is possible. Thus remember that hyperconjugation is only possible in curve. Finally, let me teach you super easy trick to solve exam questions of hyperconjugation. Well, remember that resonance structures, resonating structures are no bond resonance structures equal to number of alpha hydrogen. For example, consider these organic compounds. Find the number of no bond resonance structures. Well, in the first case, this is alpha carbon and this is also alpha carbon. 3 alpha hydrogen and 3 alpha hydrogen. There are total 6 alpha hydrogens. Hence, there are total 6 no-bond resonance structures possible. Secondly, this is only alpha carbon. This alpha carbon is linked to only one hydrogen. There is only one alpha hydrogen. Hence, there is only one no-bond resonance structure possible. Thirdly, this is alpha carbon. This is also alpha carbon. Now, this carbon is linked to this CH of benzene. This is also alpha carbon. There are total 6 alpha hydrogen. Hence, there are total 6 no-bond resonance structures possible. Thus, noted down these important questions. Lastly, which free radical is more stable? Well, there are 3 alpha hydrogen in this free radical. There are 6 alpha hydrogen present in this free radical. There are 9 alpha hydrogens present in this free radical. We already know that the more the alpha hydrogen, the more is stability. This is the most stable and this is the least stable. Thus, this is the order of stability of these free radicals. I hope that you have learned all about hyperconjugation.